All right, welcome to Earth Science Plate Tectonics Option 2. So this is going to be using more of a paper lab, looking at this fictional map, and it shows a couple of different features. And using plate tectonics, we should be able to kind of interpret what's going on here. And so a couple of things that we're going to be looking at. The first one is trying to figure out where the mid-ocean ridge is, and we'll call it the Hobbit Ridge. So it'd be in the middle of the ocean. And one of the things that we're going to be looking at in order to determine this is using the magnetic anomalies here. And so just like the Earth, this fictional planet does alternate polarities. And they have normal polarity as darker colored and white being the reverse polarity. And so looking at this map, we can see where the polarities are flipping. And notice it's not an exact same, so we can match it up. And what's happening here, that's on this map, we can actually see rocks that are right now are normal polarity, and then in the past we've had a reverse, a normal, a reverse, so on and so forth. So when we start looking at this, in the middle of the ocean, we know that this is where divergent plate boundaries occur and new plate material comes out. So your ridge had better be in normal polarity or a dark color. Now we realize that the ridge is offset in from time to time associated with those transform faults. But make sure you label that one. And again, a lot of the labeling is going to be done on this map at the end of the page. The other thing that we're going to be doing is looking at positive and negative anomalies. And you're going to try to use this scale from the first page to try to match up where exactly the plates are going to be moving apart. And so you could figure out when the plate started pulling apart. Just like we have the Atlantic Ocean opening up, this planet has the Eldron Sea opening up. And so then you could use the geologic time scale to figure out how long ago that occurred, looking at the magnetic anomalies. And then once you figure out how long ago that occurred, you can also calculate how wide this is. Notice that we have a scale down here on our map showing where 1,000 kilometers is. And so then you could use our map, our little ruler, and measure how many centimeters across the Atlantic Ocean is, or the Eldron Sea is opened up. And we know that when a sea opens up, some of the rocks move one way, some of the rocks move the other. And so what we're actually looking at is the total distance across would be the, not the half spreading rate, but the total spreading rate. We'd want to start looking from the halfway across to figure out the half spreading rate. And so if we knew how far apart these two continents were and how long it's been since this sea opened up, distance divided by time is equals rate. And so then you're going to use that to calculate a couple of different answers. Again, the half spreading rate is how far is the plate has moved relative to the ocean ridge. The full spreading rate would be all the way across the ocean, how far the Frodo continent is moving from Bilbo continent. Using the magnetic anomalies, you're going to be, again, looking on that geologic time scale. And the image, this sea has active plate tectonics. But if we start looking at this sea, we don't have the active plate tectonics. And so you can see that this plate has somehow moved relative to the North Pole. And as a result, these lines are no longer perpendicular to the equator. And so this ocean is not experiencing any more seafloor spreading, but in fact, it looks like we have a trench over here, so indicating things are getting subducting. And so then you can start looking at where these different types of plate boundaries are. Again, refer back to chapter 2 to look at the different types of plate boundaries. To answer question part B. Part C is looking at a cross section. A cross section is a side view of a land. So if we were to take this region right across, maybe from this island to the Riverdale Mountains, we could see we've got a deep trench. So what would the side view look like? It would we'd end up with maybe some rocks that are sinking underneath this plate. And so what would happen if I were to take this or this map and look at it on its side like that? What would the side view look like? In fact, using our data, we could actually draw in the side view like this and show these active plate boundaries. And so that's what you're going to be doing for the cross section. D is looking at transform faults. And again, a transform fault doesn't create or destroy new materials. And as you know from chapter 2, they just slide past one another. Sometimes these are called strike slip faults. And again, using the arrows, just draw on this map those features that you're asked to do for part D. Part E is looking at earthquakes. Earthquakes don't occur uniformly, but they tend to be clustered around certain areas, particularly where new plates are being created or destroyed, as well as associated with hotspots. And so we may see a hotspot as we're going to be looking at here in the Gandalf Islands. Now, there is a couple of questions that the lab that I have is talking or is looking at these different types of faults. We will cover the different types of faults, normal, reverse, thrust, strike slip faults. But since we're not covering those materials, I gave you the answers and put those into the lab. So I gave you those responses to kind of save us a little bit of time, especially because we haven't covered that material yet, but we will later this semester. So if you have any questions about this lab, you can upload your map and any of the, you don't have to write them on the paper. If you want to write them on a separate piece of paper, you're more than welcome to do that. But show me your work on how you're calculating those rates. What are the measurements you've collected? And again, also make sure you submit your map. If you have any questions about this lab, be sure to let me know.